We are recording. So good morning, guys. Today we're gonna go ahead and type this right here. This free response, and I went ahead and added a couple little bit more parts to just increasing, decreasing stuff that we're used to. Okay. So pretty much this is based on a free response question that we just modified. So the function f is differentiable on the closed interval, which is given here. So it has brackets, so meaning I could physically put points on the function f. This function itself is f prime. Okay, they're saying the original function f had this initial condition, and they're telling us the graph f prime, which is this one right here, is considered a semicircle, 3-line segments, like so. Okay, so line segments, the semicircle, and the other 2 line segments. Okay, so let's go ahead and find out what this is gonna ask us. So just by seeing this, guys, just whenever you see this information right here, I automatically want to think about the fun chart. So hopefully we're not, we haven't forgot that. And over, everything just slides over, right? All right, so let's go ahead and see how this information helps me answer this. So the first one that I have is, can we find an actual value of f? So let me move this way. Okay, so I don't know if you guys remember from the last Friday. I know it's a long time ago. Last Friday I talked about that we can find f of x, right? If we integrate, right? We integrate f prime of x, right? Of course, that when we integrate this, it has to be plus some initial condition, which we can totally find out from here. So that's what we're gonna do. We're gonna find out that this right here is my x, right? And this right here, the f of x, is my y. So that's what I'm gonna go ahead and do. I can find this part right here, f of -6, if I do the following. The initial condition, which is 3, right? The height it has, the c, right? The height plus the integral of the x, right? Because x's go here on my a's and b's, right? So this is 2, whatever x value they give me, and f prime, because that's the function that I know. So this equation right here will help me find any f of x value I want. In this case, they want -6. So that's what's going to go right here, -6. Okay, so let's go ahead and substitute everything that we have. And I lost my marker. Where's it? So I got 3 plus, we know the integral is just the area under the curve. So 2 -6 f prime of x. But before we go and start finding the integral, there's something that I want you to see, and it's this -6 and this 2. Can anyone remind me what needs to happen before I find the area under the curve?
Don't you have to have the higher number at the top?
Yes, so I could always flip them. Thank you, Justin. I could always flip them as long as I make this negative. So this is not plus anymore. It's going to be minus. And now I can flip the end limits. -6 is always at the bottom. And 2
Wait, sir,
is
was that an A? Is that still you?
I'm sorry?
Is that still an A? I'm like,
A is always the one on the farthest left.
no. I'm talking about the letter, like the question A. We're
Yes,
still on question A.
yeah, I'm still doing question A. I'm trying to find f of -6.
Okay. Sure.
So I'm going to go ahead and find the area, right? Because this is area. So it's going to be 3 minus the area from -6, right? -6 all the way to 2. So all this good stuff right here and all this good stuff right here. Okay, so this looks like a triangle to me. So 1, 2, 3, 4, and this is 2. So it's going to be base times height divided by 2. So that's 4. That's just 4. And this right here is a semicircle. So that's pi r squared, where radius is 2. So it's going to be pi 2 squared, gives me 4 pi. But it's not a complete circle, right? It's more of a half a circle. So this gets divided by 2. So I got 2 pi. So my entire area is this right here, 2 pi. Sorry, 2 pi, but it's below, so it should be negative, right? Any area below the x-axis is negative, and this right here is positive. So it's going to be minus positive 4, right? Because all of this was the area, minus 2 pi. So it's the same thing as saying 3 minus 4 plus 2 pi. So I got the answer will be f of 6 is equal to, if I simplify, that's negative 1 plus 2 pi. That's my answer for f of 6. So the takeaway, guys, of this is that as long as you know one initial condition, you can find f of x even if they didn't give you f of x.
Wait, sorry, I already got lost in the part where you're doing the equation for the area of a circle, and then after that, where'd you go from here?
So you were able to find this right here, 2 pi?
Yeah.
Okay. So remember, it's asking for all of this, right? We know that integral is the area under the curve. So all of this area right here, the 4 and the negative 2. So all of that gets subtracted from your 3. That's where this came from.
Wait, what? Okay. Because where's the 4 come from?
The 4 came from this one. Area of a triangle. 4 times 2 divided by 2.
So you're still doing that? Okay.
Yeah, because it's the area from negative 6, right? The negative 6 all the way to 2. Because that's the limits of the integral. Does that work?
Sure.
Any more questions, guys?
Yeah, I'm sorry.
Yes.
Where does the 3 come from? I
The 3
forgot to
came
ask.
from, remember this right here, the c is an initial condition. C is the height on a function. Remember, all derivatives have all integrals have a c, which is just telling you where exactly the function is. C is the height. So heights, and I think of heights, I think about y values. Because all of these functions would give me the same derivative. Right? The x squared plus 1, I'm sorry, I think that's an x cubed minus 7, x cubed minus 12. All of this still gave me the same derivative. Does that make sense?
Okay.
So that's why they gave me this. So I have an idea, oh snap, it's the 3, so I'm gonna probably look at this one and not the rest. Does that make sense?
Okay. How did you get the idea? How did you get the idea of 3? How did you get the idea of 3 minus 4 minus 2 pi? Where did you get that idea? Like, or how did you get to that equation or something?
It was because of the area under the curve. So remember the integral? The integral from an a to b is the area under the curve from a to b. So from, what is the area from negative 6? Whoops, whoa. Negative 6 to positive 2.
Okay.
That's what they're asking me.
All right.
The next one says f of 5. So f of 5, that is the initial condition 3 plus the initial condition's x value, which we know the x value was given to me. It is a 2 and the value I'm looking for, which appears to be 5, right? Because that's the number they gave me for the function that they gave me. So I'm looking for the area on the interval from 2 to 5. So I'm looking at this area from 2 to 5. And I believe I can split into 2 triangles right here, if I'm not mistaken. So I want to find this area of the green. So this is 1, and this is a height of 2, and this is 2. So I can find the area, base times height divided by 2, base times height divided by 2. I got that this was 1. And this one is 2 times 2 divided by 2. I got that this was 2. So it's going to be 3 plus the first area that I found, the first area right here, which was 1, plus the second area that I found is right here, which was 2. 6 is what I got. Is that okay with everyone? That is the value for the function at 5. Like, how cool is that? Like, we don't even know what the function is, but I can tell you its height. I can tell you its value just by knowing one initial condition, which was this right here. Which was this right here. Any questions, guys? If not, I did this one very, very similar last week also. Okay, part B says, can you give me a general equation to find any value for f of x? Well, we can. F of x is equal to the initial condition, in this case was 3, plus the initial condition's x value, which is 2. And this right here will be my x value, right? Because I don't know what value it is, but they want me to find it. And then the function, sometimes it gets confusing. You put another x, I'll put another value. So I'll put a t or any other variable you want, just so you know that you can distribute it right here. You can substitute it, sorry. So this would be the equation, an expression, sorry, that solves for f of x. Any questions on that? And we used this the entire time. We used it here, and we used it here. Any questions, guys? No?
Nope.
Alrighty. Let's go ahead and do this one. Same graph, but this is part C. So find f of 4, f prime of 4, and f double prime of 4. So
Wait, sir, I didn't finish writing down
got it.
the equation for B.
Go for it. I'm so sorry, guys.
How many more slides?
Ooh, this one
Alright,
goes
sir.
all the way to Z on the
Thank
FRQ.
you.
Z.
Yeah. It's called an super FRQ. No, I'm just kidding. I'm kidding. Alrighty.
April Fools.
So let's find f of 4. So f of 4,
Okay,
guys,
G.
f of 4 is pretty much the same equation, 3 plus the initial condition, right, of 2, the value that they want me to give me, which, I'm sorry, what they want me to find, which is 4, right, because this is 4, and the integral, right, of the given function, and so forth. So I'm gonna do the exact same thing. I'm gonna integrate from 2, right, from 2 to 4, right here. So from 2 to 4. So all of this area. So as much as I want to make this a triangle, which I already know the triangle's area, we already said it was 1. I don't know this triangle's area right here, this little trapezoid. Unless I break it up into two triangles and a square, if that's what you want to do. But this is a good time to review area of a trapezoid. Base 1 plus base 2 divided by 2 times the height. And remember the bases are the different lengths. So this one base is another base. And the height is the distance between the bases. So right here, it looks like this height is 2 plus the second height, which is a height of 1 divided by 2 times the height is the distance between the two bases, which also appears to be 1. So I think I have 3/2 for this little trapezoid right here. So I got 3 plus the first area that I found, which was 1, plus the second area that I found, which was 3/2. So I got 4 plus 3/2. I believe you don't have to simplify this, perfectly fine. But if you did, I think this was multiplied by 2/2, which is 8/2. 8/2 plus 3/2. 11/2? Question mark.
So I got lost
Which part, Albert?
starting actually from the very beginning. Oh my God.
So this is the same as the first A and B questions. The same formula because they want us to find an F value. Yes.
Okay.
And then I want to find the area from the interval 2 to 4, which is this little funky triangle trapezoid stuff. You can
What'd you
find
get?
it. I'm sorry?
How'd you get 2 and 1 then? Or is it, oh yeah, 2 spaces.
Yeah, 2 spaces and 1 space. Sorry guys, I should have made the picture bigger. This right here, this height is 2, and this height right here is 1. And I just compared it to this little right here. Does that make sense?
Hang on.
Any other questions, guys?
Mm.
Yes, no?
Mm.
Where did you get the area where it says 2, 4?
2, 4? Oh, no. This is this right here is what this means. This is what that means. Like,
Oh, okay.
the integral is the area from 2 to 4.
Oh, okay. I see.
Yeah. The next question is not as bad, guys. It says f prime of 4. This one looks scary, but it really isn't. It's telling you what is the y value, right, at x equals 4 on f prime. Well, super easy because the function f prime is this one right here. So at f prime, I'm sorry, at f 1, 2, 3, 4, at 4, right? 4 is right here. What is that y value? Hopefully you see it. F4 is equal to 1, right? The height right here, the y value right here is 1. This is 4 and 1. Is that okay with everyone? Just looking at the graph.
Wait, 1, 1.
They're asking you what is the y value at x equals 4 on f prime.
Okay.
And they gave us the graph f prime. Yes, no?
Okay.
So it was literally looking at the graph. How about f double prime? Ooh, that's nice. F double prime is concavity, right?
Yeah, concave.
Concavity, aka rate of change of the slope. Sorry. So what is the rate of change at this value right here? So at this x equals 4, what is the rate of change right here? Right, it's linear, so I could legit count my rise over run because it is linear, right? This right here is a line, and hopefully you can see with me, I rise -1, I run 1, rise -1, run 1, and I keep on doing that. So what would be my slope? Negative 1, right? -1 over 1, which is still -1. This was my rise, this was my run.
I thought you said you rose -2.
Not exactly, Albert, because look how much I went down. Can I erase that, guys? Because I think it looks really messy.
Okay.
Like this line right here, what is my slope on that line? At 4, well, I don't have to worry about it exactly at 4 because this line looks like it went down 1 and rose. Down 1. You see what I'm saying? So my slope is -1 over 1. Or just -1. Is that okay with everyone? No? Okay, we're almost done, guys. Don't worry. I believe there's only 2 more and that's it. Horizontal tangents. When is an only way we can have horizontal tangents? So think about it like this, like a little roller coaster can only have a horizontal tangent when it's either at its maximum, its minimum, or a saddle point. Right? Because its derivative, right? F prime has to be 0. Right? Its slope has to be 0. So that only works when it's at a max, min, or saddle point. So given what you know, how do I find out when I have a max or a min? What happens? Do you guys remember your fun chart? You don't have to write it down.
So what were you asking again? Forgot.
When does a max or a minimum occur?
Oh, max is when it goes from positive to negative.
Uh-huh.
And then minimum is goes from negative. Yeah, vice versa.
Yeah, vice versa. Negative to positive. So we're going to check that in our graph of f prime. And it changes from positive to negative, right? This is positive, this is negative. Right here at x equals -2, and right here at x equals 2, because this is negative, this is positive. So at x equals -2, is it a max or a min?
Max.
Max. And at x equals 2, it is a min.
Min.
Okay, so we got the saddle point. I'm sorry, we got the horizontal tangents. So which one is a minimum according to this? It'll be this one. So they both have horizontal tangents. So it says justified, so let's write it nicely. F has horizontal tangents at x equals plus or minus 2, right? And then the second question is asking relative maximum and a relative minimum. Sorry, I can't type. Relative minimum at x equals 2 because, and we just state what happened. It went from negative, I'm sorry, f prime went from negative, went from negative to positive. If you find the same way to saying this with less words, you're still golden, guys. All they really care about is you talk about the function itself that they asked you about, the values, of course, right? The answers, and the function you were given, and some sort of rationale. Any questions, guys? This one should be a little bit more familiar since the video of Nimsy talked about it a little. Can I continue?
Yes, sir.
Okay, we're almost done. This
Yeah.
is talking about decreasing. When does a function decrease? So f decreases when f prime is, who knows this answer? If you want, I can go back to the fun chart in the slide before. When
Positive and
does,
negative.
yep, it decreases, right? It decreases when, I'm sorry, it decreases when it is negative. Decreases when f prime is negative. So right here, it is all negative. F prime is less than 0. So that is from x equals 2, sorry, negative 2 and x equals 2. So for E, f is decreasing at the interval that we found, negative 2 to 2. Because f prime is less, less than 0. I think that's the shortest we can write it. And it talks about everything. It talks about what they want, which is f. It talks about the decreasing. It talks about the answer and why. So this would be pretty good. The next one says f prime is concave down. When is concave down? Well, let's see if we can see it with the fun chart. When can I see when something's concave down? So f is concave down when f prime is, did anyone get it? Concave down, right? Concave down when it is negative, when it is decreasing, when the slopes are decreasing, when f prime is decreasing. So we're gonna look at this right here. Let me pick a different marker, green. Oops, green. So we're gonna go ahead and see when is this function decreasing. So do you see this right here? It's decreasing, right? If this was a roller coaster, it's decreasing, 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 all the way up to here, right? Because this looks like it's horizontal. So, and then it starts decreasing from here to here. So f is concave down from the interval -6 to 0 union from here, which is 3 to 5, because f prime is decreasing. I should probably write this all up. But I didn't fit, damn it. Decreasing. Any questions on that, guys?
Oh, okay, concave down is just the one that you see that's heading going further, closer and closer to y = 0, and then go underneath it, negative.
One more time.
So, concave down is basically just anything that's getting closer and closer to 0 or it's at negative.
No. When the slope of the f prime is decreasing. So all of this has a negative slope.
Okay.
All of this. This too. Oh.
Yeah, that was what I meant to say.
Okay, yeah. That works. Can I move the slide or?
Yeah. Okay, go ahead.
Okay. I believe this is my last one. Oh, points of inflection. F has inflection points when what happens? We did pretty good on this lesson.
When it goes from concave down to up, and then vice versa.
Yes, vice versa.
Yes.
Changes concavity, right?
Yeah.
Okay. So in other words, when f prime, how can I say, f prime changes from increasing to decreasing, right? So when does the concavity change? So we agreed that all of this is decreasing. All of this is decreasing, except here when it starts increasing. And except here because it starts decreasing. So I should have an inflection point at x equals what? When did the concavity change?
And x = 0.
And x equals?
That's 2. Or no, 3.
3. Does that make sense to everyone? So f has inflection point at x equals 0 and x equals 3 because f prime changed from, what can I say, increasing to decreasing, or vice versa, right? But doesn't the point x equals 3 on the curve? I'm sorry, one more time. So x equals 3. But we're talking about, we're not talking about the derivative at that one. We're talking about the increasing, decreasing, not exactly the derivative. Does that make sense? We're talking about its slope. Yeah, awesome. Okay, this one is the last one, promise. So these are called super FRQs. So pretty much you get a question and can be tied up to different units. And I really enjoy these, so I thought this would be a nice start before they get really crazy. So f double prime of -5. So at -5, 1, 2, 3, whoa, 1, 2, 3, 5. So right here. So remember, we're talking about the second derivative. So what would be the rate of change of this line? So as mentioned, guys, you're literally looking at the slope of the slope, right? So this f prime is already talking about slope, right? The slope of f. So right here, what would be that slope? Well, it's linear. We could probably go ahead and count the slope, which looks like it's gonna be 2, right? Oh, it even says right here 2, and 1, 2, 3, 4. So it's gonna be down 2. It's gonna be rise -2, and it's gonna run 4. So my slope here would be -1/2. So f double prime at 0, well, f prime at 0 right here would be that slope right here. It would be that slope at 0. Yes, this one would be 0. It is a semicircle, guys, so hopefully you know that this right here, you can draw a horizontal line. So the slope right here would be 0. Now we mentioned it before in the previous question, f double prime of 2 right here. That one is what we call a sharp turn. So what can we say about that derivative? What is the rate of change here? There you go. That one would not exist. It does not exist. Because we're trying to find the concavity compared to the last question, which was reflecting back to f, not f prime. Hopefully that answers your question.
Sure. I actually got missed out. 1/2 for -5, and then 0 for f double prime of 0, and then f double prime of 2 does not exist.
Yes. Yeah, because this right here, I don't know how to draw my tangent line to that. Because it's a sharp turn, you could probably draw different ones yourself and we would get nowhere, right? But in -5, if I told you draw me a tangent line to this right here, you would probably also see that, hey, this is along a line. So you would probably also get this slope. This right here, hopefully you see that this is a circle, and that is the only way I could draw a horizontal line at 0, right? Because it's right where the origin is. And then this one, well, I have no idea. I could probably go vertical or this way or square, maybe this way or that way. Does that make sense?
Wait, explain to me with f double prime -5 again. What happened there?
This right here is where this is -5, and I don't know, some point.
Okay.
So from right here, if I told you find me the slope at this point, you would see that, hey, there is this line right here, this line segment. So how do I find the slope of that line segment? We learned it in middle school. Pretty much the easiest was to count the rises over the runs. So it was height of 2 and 4, but it's going downward. So it's -2 and run 4. So I did -2 over 4 and I reduced it -1 over 2 as my slope for that line segment that includes -5.
Okay. And then f of 0 does not have any, so.
Well, be very careful. Does not have any does not exist. And slope of 0 is very, very popular. It's horizontal tangent used in maximums and minimums. So I wouldn't say it doesn't have any. I would just say slope of 0 or a horizontal tangent.
Slope of 0?
Yes.
Or no?
Yeah.
Yeah. Slope of it. So at f double prime equals 0, it's just slope of 0. Wait, what is it again?
Yeah. Let's say you are running. You run the mile. I don't know. You run a marathon or something, and you're going at a constant speed of a mile for. I would never run. Okay. You would go 6 minutes per mile. Okay. So your graph would look like this, something linear, right? Because you're going 6 minutes per mile. If I derive this graph, right, this linear graph, my slope would be horizontal. So this is a slope, a horizontal tangent. So here is what we're doing too. This is not changing, it's slope of 0. Because, I don't know, at some point you were constant, that's something, f was constant, so its slope was 0.
But doesn't the circle look like quadratic? Semicircle?
But this is f prime.
F prime?
Yeah, we're trying to say what's happening at, I'm sorry, we're trying to happen what happens at f double prime. What is the slope of this right here at that point?
Okay. You just don't. All right.
Okay. That's all I have for you guys. So what I went ahead and did, this will be due next Friday. So what I went ahead and did, guys, and I'll upload it right now. It will be the same graph. All I'm changing is every number here. Other than that, you should be golden. I'll upload it right now.